Welcome to the trigonometry topic. So trigonometry is a massive part of mathematics. It's also a massive part of the world that we live in because of its importance in so many ways. So we're going to learn basically how to use trigonometry, and also in time we're going to learn in what ways we can use the mathematics. Just as a very brief introduction, if you appreciate being able to find where you are in the world on your mobile phone using Google Maps, or if you want to find somewhere that's near you, then you might use your mobile phone, and your phone uses satellite GPS technology to track you. That's my wee satellites on the picture here. Effectively, what happens is that if you have a number of different satellites all honing in on a point, then you can determine where you are. And they use trigonometry for all the calculations, quite complex mathematics, but effectively what we're going to do in this topic is the starting point of all that. Trigonometry is hugely important. So you might not have to do a lot of calculations in your life and your work, but we appreciate all the people who need to use it to get on with a lot of the things that we enjoy. Trigonometry, the actual name of it, comes from two parts. From the Greek. Trigonon is to do with a triangle, tri meaning three. So that's part of the triangle. But in metron, anytime you see metri at the end of a word, it means the measurement of it. Is to do with the measuring of something. Geometry, geo meaning world, and the measurement of the earth. That's the origins of the word geometry. And telemetry, other words meaning to measure. So what we're looking at here, we're going to come up with a tool. Trigonometry is about the measurement of triangles. It's to measure or to calculate the lengths of sides. It's to calculate angles, and we're going to learn how to do both of these. So let's have a look at some of the basics. Now, in class, we would do this as a very practical exercise. If you've got a bit of square paper, you can have a go at this, but I've kind of prepared early. What I would normally say is draw a right angle triangle on a grid of paper. And the one that I've drawn at the top would be one like that. So this one here. And what I would get you to do is to make it of a certain base length and a certain height. So in this case, it's 3 by 5. So I've drawn a 3 by 5 triangle, and I would get you to pick some numbers. It doesn't have to be the same. It could be a 1 by 4 or a 2 by 2. And then what I would get you to do is to enlarge that. In other words, make a scale factor of 2 and a 3. So a scale factor of 2 means all the sides are double the original, and a scale factor of 3 means all the sides are 3 times the original. And we would have the 3 diagrams on our page like that. So all these triangles, really interestingly, have the same angle sizes. So one of the really important things to realize is if you enlarge a triangle, this angle here on the top left side here is exactly the same size as this angle here, and exactly the same size. So although we're doubling or tripling the edges, we're not doubling or tripling the angle. That stays the same. We would expect that of a rectangle. If we enlarge a rectangle, suddenly the angles don't change the size. So it's odd that some people think that would happen with other shapes, but it doesn't. Okay? So what we do in this little experiment is that I would get you to work out this idea of the ratio of the sides. So we've got 3 and 5, and so what I would like you to be able to do is take the ratio of your sides. So in this case here, 3 over 5, and I would like you to work out the ratio of that side. 3 over 5, I'll do it up here. So 3 divided by 5, or 3 over 5, in a calculator is 0.6, and that's good. So if you then have a look at the next triangle that you've got, number 2, let's have a look at the ratio of those sides here. So we've got 6 over 10. 6 over 10, well that's the same as 0.6. And in this one here, 9 over 15, 9 over 15, 9 divided by 15, you either could simplify that, divide each side by 3. Well, you can see, of course, that we get the same answer each time. What we can say is that the ratio of the height and the base, 3 over 5, 6 over 10, 9 over 15, always generates the same number, 0.6. And so if I were to measure the size of this angle here, which if I had an angle measure, a protractor, I would be able to measure that this angle here is about 31 degrees, which means that this one's 31 degrees and this one's 31 degrees. So in other words, no matter how big the triangle is, okay, if we work out that the ratio of the height and the base is 0.6, okay, so the ratio is 0.6, and if we remind ourselves that that must mean that this particular angle here is 31 degrees, if we kind of bank that, then any time we come across a ratio of 0.6, we can be guaranteed that the angle is 31, or if we measure the angle as 31, we can tell that the ratio is going to be 0.6. So it's, in other words, it's a kind of fixed relationship. Okay, now you will find, and if you did that with other things, I'll show you in a minute. Let's just show you. This is from a lesson that I did, and we generated a whole lot. People chose all sorts of different heights and bases, so they got different ratios, and they measured the size of their angle, and we found, of course, that if the ratio of the sides is different, it means the triangles have a different size, and so the angles is going to be different. But what we found was that, you know, no matter how big the triangle is, so for instance, this one here, we found that the ratio was 2. It means that the height was double the base, so it could have been like a 4x2 triangle. And what we've found is that the angle down here is always 62 degrees. You know, that would mean that if we had a triangle that was, you know, 20x10, we would know that that angle is always 62 degrees. So if we know the ratio and the angle that goes with it, then we can work with that. Okay. Now, of course, there's so many possible ratios and so many angles that we can't keep track of them. But the good news is that your calculator can. And we've got a way of getting that information instantly using a particular button on your calculator, okay? And in this case, if you've got your calculator, the name that we give to this ratio here is the tangent ratio. The tangent ratio. That's what we're going to be looking at first of all. The tangent ratio is the height divided by the base. We'll rename them in a minute. But if you got a scientific calculator, and if you find the button that says tan, which is short for tangent, and if you press 31, because that was the one I was working with, as in the tan of 31 degrees, you'll find, well, it's not absolutely exact because we're kind of approximating here with my measurements. If you do tan 31, you get the answer 0.60086 and so on. It goes on and on and on. But it's effect, as far as we're concerned, 0.6 is good enough. Okay, so our calculator tells us the information that I demonstrated, and if you do the same for, you know, the tan of 2, you'll find, if I just do that, I've got my calculator, tan of 2 equals the ratio is 2, so the tan of 62, get it the right way around, tan of 62, it says 1.88, that's the exact value. Somebody measured it at roughly 2, and that's fine, okay? So, that's the idea behind trigonometry, is that there's this fixed connection between the ratio of two sides when we make a fraction and the angle of that triangle. Okay, so let's move on and look at some names. So, here's a typical right-angled triangle, and as we were looking at, sometimes we're interested in one particular angle. We know that one of them's got to be 90, but there's two other ones. So say we look at one particular one that's of interest to us. We're going to name the three sides of the triangle. So the first one, these are the three names on the right-hand side. The first one we name is always the one opposite the right angle. So you go away from the right angle, and that side is called the hypotenuse, which you might remember if you've studied Pythagoras' theorem. It's also the hypotenuse, the side opposite the right angle. So that's good, no change there. The second side that we can name is the side that goes away from the marked angle, the angle that we're interested in. So if we go away from that to the opposite side, we call that the opposite Okay, that's called the opposite side. And the side that we haven't marked yet, that's the one down here at the bottom at the moment. And it's in between, notice that it's in between the two angles that we know, the right angle and the marked angle. And we call that one the adjacent, which means next to. Adjacent. Now we don't have to write out all the words every time. What I tend to, you can either write the initial H, O and A, or if you like, just to kind of remember a wee bit more of the name, you can use the first three letters. And I tend to put a circle around the letters so that it doesn't get confused with any lengths of sides or any letters that I've got marked there. Okay, that's how we name the sides. And if I were to go down, let's see if I can pick this up a little bit. Can I? Yeah, okay. So, can I bring this up? No. Let me just check down here. Let's have a wee look at this one. The right angle's not always, of course, on the bottom. Sometimes, like this one down here, it's on the top. The triangle's basically been moved around. So we've got a marked angle, the green. We've got a right angle. And let's just name the sides down here. So what we've got is the right angle. Opposite the right angle is the hypotenuse, HYP. Opposite the marked angle, we go over here and we can put OPP for opposite. And then the one that's not been labelled yet, you can just do it as that, and the other one is the adjacent. Okay, so that's how you mark or name the sides of the triangle. So we're going to go on now and try and work out how to use this ratio. So let's have a look at what we know so far. Right, we've got the three sides of our triangle, and in this green box I've written down a little formula, and all that formula is a formal way of working out what I just explained a little bit earlier, which means that the opposite and adjacent at the moment is effectively our height and our base. So remember when I did that example of a 3 and a 5 triangle, and I measured that the angle was about 31 degrees. So 31 degrees is equivalent to the ratio 3/5. But because 31 isn't the same as 3/5, that's why we have to put the word tan in the front to say, look, it's the tan ratio. So the ratio that's connected to 31 degrees is 3/5 or 0.6. Okay, so we've formalized it in a bit of an algebraic way, but we're basically just saying what's the angle and fraction that's connected. Okay, and we do that as tan x equals opposite over adjacent. So that's the formula that we're going to use for all of our solving at the moment. So let's have a look at solving a particular problem. So look at example 1. Calculate the height A of the triangle. So here we've got height A, we've got a base of 10 centimetres, and the marked angle is 30. We've got a right angle there, which we need. We've got 30 degrees. So what we're going to do is we're going to write out the formula as it's given here. So we've got tan x, tan, oops, that was a wee bit. Let's rub that out, try it again. Okay, tan x equals opposite over adjacent. Well, we're going to substitute as you always do in a formula. We know that x is the angle, so that's 30 degrees. But the problem is that we don't know what the opposite and adjacent are because we haven't named the sides. So you can do that right away, or you can do it at the point where you kind of need to know. So let's have a look. Opposite the right angle is the hypotenuse. Oops. Hypotenuse. Opposite 30 degrees is the opposite side, and the other one's the adjacent side. Now you see that there's things written on these sides, so I'm just going to put a wee, you don't need to, especially seeing I've got different colours, but there we go, just as a wee reminder, opposite, adjacent, hypotenuse. So when it comes to our formula, then it's quite easy then to tell. The opposite is the side marked A, and then the adjacent is the side marked 10. Okay, so that's us put in our information. So we need to solve this problem for A, right? Tan 30 I can work out on my calculator, but at the moment we've got A divided by 10. Now we've got an equation with a fraction in it, and the best way when you're dividing by a fraction is just to multiply by that fraction. So what I'm going to do is if I multiply the right hand side by 10, then they're going to cancel out. Divide by 10 and multiply by 10 cancel out. But of course I've got to do the same thing on the other side. I've got to multiply to keep the equation balanced. So what that leaves me with is 10 times tan 30 equals A. And the good news is that I can do that on my calculator. I'm going to swap it around, so the A at the start. And on your calculator, you do 10 times the tan of 30, 10 multiplied by, press the tan button and press the number 30 and then equals, and you get 5.7735 and so on. Okay, 5.7735. Now you'll always get lots of numbers usually. So what we want to do is to cut it either maybe to one decimal place. So if I cut it there, 5.7, the next digit's a 7. So that would give me A equals 5.8. I'm going to round up. My units are in centimetres, and I'll put to one decimal place. Okay, so that's how I use trigonometry to work out the height of this triangle would be about 5.8 centimetres. I've got one more example, so stay with me. Here's number 2. It says calculate the length of the line AB. Okay, so we've got 73 degrees in the angle, 2.6 metres, and we don't have any letter. We've got the line AB, so it's easier sometimes to add a letter. So I'm going to call that, just going to call that D for distance, but you can call it anything you want. And what we'll do is we'll write out the formula, tan x equals opposite over adjacent. I know that the angle that we've got is 73, so tan of 73 degrees is equal to, well, I don't know where to put my opposite and where to put my adjacent because I haven't labelled the sides. So let's do it. Opposite the right angle is the hypotenuse. Opposite the marked angle, 73, is the opposite, and the other one is the adjacent. So, opposite sides, have a look on the diagram. What's that? Opposite is D, and adjacent is 2.6. So now I've got the equation tan 73 equals D divided by 2.6. Okay, well, we can sort that out by, again, multiplying by a number to get rid of that dividing number in which we do the opposite, which is multiply. So if I multiply the right hand side by 2.6, they'll cancel out, but of course I've got to multiply the right hand side by 2.6. So if I update that, I've got 2.6 multiplied by tan 73. I didn't put a multiplication sign, you don't always have to, equals D. Flip it around, take my calculator, 2.6 multiplied by, press the tan button and press the number 73 equals 8.5042. 8.5042. There's too many digits there. I'm going to cut it after the first decimal place. We round down because of the 0, so we can say that D is 8.5 to one decimal place. And if I'm being really proper in my reporting, I wasn't actually asked to calculate D. I was asked to calculate AB. D was just something I used to help me, so I'm going to rewrite it. AB equals 8.5 meters to one decimal place. There we go. Now there's one tiny thing, it's an important thing. If you don't get the same answers as me, it might be because your calculator is in the wrong mode. So what you want to do is to look on your calculator screen. You're looking for one of 3 letters. You're looking for D, G, or R. Or it might say DEG, GRAD, or RAD, like RAD. It's really important that at the moment that we work in degrees. So your calculator has to be in that mode there. Some calculators have a button that says DRG on it, and you just press it to toggle between them. The Casio ones tend to have a you need to go into shift mode into the setup, and you can select, what did I just say, shift mode, and that will give you, you would press number 3 at that point. Okay, so shift mode and then press 3, it will take you to degrees mode so that they all work out. Okay, so that's it's a bit of a long explanation. The next video's got some practice questions to go in and have a go at them as well. Hopefully that's been helpful.